Okay, in the previous class, we have discussed about the demonstration of clustering rule process on student.arff dataset using simple k-means algorithm. First, we have prepared the student.arff dataset. After that, have explained the simple k-means algorithm and its process and the algorithm related to the simple k-means algorithm by taking one example. We did it. After that one, we have loaded the student.arff file into the Vika. Okay, first we have did the pre-processing. After that one we have went for the clustering tab. In the clustering tab we have selected the simple k-means algorithm and we have applied the simple k-means algorithm. While applying the simple k-means algorithm we have made the clusters. Okay, we have changed the clusters into number of. Okay, that is the input for that simple k-means algorithm. Based on that one it will gives the results. It will form the clusters. Okay, that is the previous class explanation. Okay, coming to the sixth unit, guys. Okay, okay, in the sixth unit, we have discussed about these first concepts, basic concepts, and next related to the uh, cluster analysis and different types of clustering and different types of clusters we have discussed in the sixth unit. And simple k-means algorithm we have already discussed, and bisecting k-means and its strength and weaknesses also we discussed, guys. Okay, the thing we have to discuss is in this class, that is agglomerative hierarchical clustering. That is also one of the type of clustering. Okay, but the k-means algorithm is the oldest one. Okay, but nowadays also we are going to use this simple k-means algorithm. Okay, the agglomerative hierarchical clustering is the second type of clustering algorithm. Okay, now we are going to discuss about this algorithm. Okay, by taking one example, we are going to discuss about the agglomerative hierarchical clustering, and we are going to discuss about the algorithm also. Okay, the next we are going to discuss about db scan. Okay, now in this class I am going to discuss about what is agglomerative hierarchical clustering and basics and algorithm related to the agglomerative hierarchical clustering. And I am going to take one example with the help of this agglomerative hierarchical clustering, how we are going to form the cluster also. Let us see it, guys. Okay, understand, guys? Till now we have these three parts we have discussed. Okay, the leftover things is agglomerative hierarchical clustering and db scan. Okay, let us start the discussion related to the fourth one, that is agglomerative hierarchical clustering. Okay, that is also one of the clustering analysis technique. Okay, guys, one thing I want to tell related to this sixth unit, guys. Gunshot questions we are going to get in this sixth unit, guys. Okay, simple k means algorithm. Okay, algorithm related to simple k means algorithm. Problem related to the simple k means algorithm. Okay, bisecting k means algorithm. Okay, you are going to, and sometimes they will ask about the uh, clustering rules process on clustering analysis. They will ask direct questions. Okay, that is why you have to concentrate the sixth unit, simple unit. Okay, okay, the fourth topic related to the sixth unit, that is agglomerative hierarchy clustering, guys. Okay, simple, guys, just concentrate it. Okay, then you can easily able to understand this one, right? Okay, let us start the discussion related to the agglomerative hierarchy clustering. Okay, okay, this is the second topic related to the second clustering algorithm we have discussed. First, we have discussed the simple k-means. In that one, the subtype is bisecting k-means. We have discussed. The second technique related to the clustering is, that is agglomerative hierarchy clustering method, guys. Okay. Previously, what we have discussed, guys, that is k-means algorithm, simple k-means algorithm. That is older, but compared to many algorithms, but we are going to still use this simple k-means because of this widespread use case. Okay, the k-means algorithm is the oldest one, but comparing with the many clustering algorithms, okay, still we are going to use that one, simple k-means algorithm, guys. Okay, because of this widespread use, right? I'm again explaining this. What is this agglomerative hierarchy clustering? This is the second type of clustering technique, guys. Before that one, what we have discussed is the K-means algorithm. That is the older one. But compared with this, the K-means algorithm, agglomerative algorithm, K-means algorithm is chala, we are going to use widespread use, guys. Okay, compared with the new algorithms, but the older one we are going to use in widespread applications. Okay, this agglomerative clustering is one of the common type related to the hierarchical clustering, guys. Okay, in the hierarchical clustering, this agglomerative hierarchical clustering will comes. Okay, this is we are going to form the clusters based on the object similarities. The two objects are having the similarities means we are going to group that one. We call them as a cluster, guys. Okay, this process we call them as a agglomerative. Okay, agglomerative means agglomerative nesting, guys. Okay, ఇలా కంబైన్ చేయడాన్ని ఏమంటామంటే it's based on the similarity of the objects. Okay, if the objects are similar, we are going to group that one. We are going to form the clusters. This we call them as a agglomerates, agglomerative nesting. Okay, here in this algorithm, first we are going to start. Okay, each object. Okay, that is that one as a singleton cluster, guys. Okay, we are going to take that one as a singleton cluster. Agglomerative hierarchy cluster na agency and we have to write down this one, guys. Agency means agglomerative nesting, other name for the agglomerative hierarchical cluster. Okay, in the agglomerative hierarchical clustering, what we are going to do is we are going to group the objects based on the similarities. Okay, guys, I'm proceeding for the next slide. Okay, in this agents, okay, first what we have to start is we have to start each object as a singleton cluster. Okay, next is next what we are going to do is we are going to play pair of clusters successively merging the clusters. Okay, to form a బిగ్ క్లస్టర్స్ అనమాట. ఇక్కడ ఏం చేసుకుంటామంటే ఒక ఫస్ట్ సింగిల్టన్ క్లస్టర్ తోటి స్టార్ట్ అయ్యి ఓకే నెక్స్ట్ ఇంకో క్లస్టర్ ని మెర్జ్ చేసుకుంటూ ఫైనల్ గా ఒక బిగ్ క్లస్టర్ ని ఫార్మ్ చేసుకుంటా వరకు చూసుకుంటా ఉంటాం. వెన్ వీఆర్ గోయింగ్ టు ఎండ్ దిస్ మీన్స్ ఓకే దట్ ఇఫ్ ద బిగ్ క్లస్టర్ కంటైన్స్ ద ఆల్ ది ఆబ్జెక్ట్స్ దెన్ వీఆర్ గోయింగ్ టు స్టార్ట్ ది ప్రాసెస్. ఫస్ట్ ఒక we will going to start from the one cluster. Okay, that will be merged with the sixth cluster. Okay, until it will get the big cluster. Okay, and moreover that it has to come all the objects also, then only we are going to stop this process. Okay, overall finally we are going to represent this result in the form of tree brace representation, guys, that we call them as a dendrograms, guys. Okay, this is the process related to agglomerative hierarchical cluster. ఒక క్లస్టర్ తోటి స్టార్ట్ అవుతాం. ఓకే, okay, in the for suppose in the exam if they asked about the dendrograms means you have to write down about this agglomerative hierarchical clustering, guys. Okay, it is a tree based representation. Okay, మీకు ఇంకొక పాయింట్ చెప్తున్నానండి. ఓకే, మీరు సీరియస్గా తీసుకోకపోతే మాత్రం డేటా మైనింగ్ చాలా కష్టపడతారు చెప్తున్నాను. యు ఆర్ ఇన్ ద క్రూషియల్ స్టేజ్, దట్ ఈస్ 3-2. మీ సీనియర్స్ వచ్చేవాటికి మంచి ఓకే రైట్ నో మీరు వచ్చేవాటికి 3-2లో ఉన్నారు కాబట్టి ప్లేస్మెంట్స్ గురించి ఓకే, క్రూషియల్ స్టేజ్లో ఉంటారు. ఈ టైంలో ఏదన్నా అటు దిడికి ఏదైనా జరిగి ఆగిందంటే మాత్రం చాలా బాధపడతారండి. అందుకని చెప్పేసి 3-2 వచ్చేపాటికి అందరూ కూడా చాలా జాగ్రత్తగా కంప్లీట్ చేసుకోండి. ఏ సబ్జెక్టు కూడా ఆగకూడదు. ఓకే, నేను అందుకని మీకు పదే పదే చెప్తున్నాను. చాలా మంది మీ సీనియర్స్ వచ్చేపాటికి అదే తప్పు చేశారనమాట. అప్పటివరకు 3-2 వరకు కష్టపడి మంచిగా కంప్లీట్ చేసుకున్నారు, మంచి పర్సంటేజ్ తెచ్చుకున్నారు. క్రూషియల్ టైంలో వచ్చేపాటికి కొంచెం ఫ్రీ అయిపోయారు అనమాట. అయిపోయేపాటికి ఏం జరుగుతుందంటే కనుక సబ్జెక్ట్ అయిపోవడం జరుగుతుంది అనమాట. ఓకే, అందుకని చెప్పేసి ఈ అన్ని సబ్జెక్టులు సీరియస్గా తీసుకోండి. మోర్ ఆఫ్ ద డేటా మైనింగ్ వచ్చేప్పటికి ఇంకా సీరియస్నెస్ తీసుకోవాలండి. ఓకే, అండర్స్టాండ్ గైస్? హోప్ యూ హ్యావ్ అండర్స్టాండ్ దిస్ మై పాయింట్, రైట్? ఓకే, coming to this agglomerative hierarchical cluster. Okay, the finally result will be represented in the form of tree based representation, guys. We call them as a dendrograms. Okay, let us see the algorithm related to that one. Okay, before that one, okay, what are the types related to the hierarchical clustering? There are two types of hierarchical clustering will be there. That is, one is agglomerative hierarchical clustering and diverse clustering, guys. Agglomerative clustering. Second one is diverse hierarchical clustering. Okay, another name we call them as agglomerative hierarchical clustering కూడా అనొచ్చు, అలాగే diverse hierarchical clustering. Okay, in this agglomerative hierarchical clustering, what we are going to do is we are going to start from the bottom up approach. Means we are going to start from the leaf node to root node. That is individual objects to one big cluster. That is the process we are going to follow in the cluster. మనకి ఎగ్జాంపుల్ గా తీసుకోవాలంటే కనుక స్టూడెంట్, ఫర్ ఎగ్జాంపుల్ 60 స్టూడెంట్స్ ఉన్నారనుకో, ఒక స్టూడెంట్ దగ్గర నుంచి స్టార్ట్ చేసుకుని మొత్తం అందరినీ కూడా కంబైన్ చేసుకుని ఓవరాల్ గా ఒక బిగ్ క్లస్టర్ ఫామ్ చేయడం. దట్ ఈస్ వి కాల్ దెమ్ యాజ్ agglomerative hierarchical cluster. Okay, coming to the diverse cluster, diverse to hierarchical clustering means this is the opposite phenomena related to the agglomerative clustering. Okay, opposite phenomena అండి. ఇక్కడ ఏం చేస్తామంటే కనుక బిగ్ క్లస్టర్ ని తీసుకొని దాంట్లో డిఫరెంట్ ఆబ్జెక్ట్స్ ఉంటాయి. అంటే మీ 60 మెంబర్స్ ఆబ్జెక్ట్స్ ఉంటారు. దాన్ని ఇండివిజువల్ గా వన్ బై వన్ డివైడ్ చేసుకుంటా స్టూడెంట్స్ కింద డివైడ్ చేసుకుంటూ వస్తాము. దట్ వి కాల్ దెమ్ యాజ్ ఎ డైవర్స్ హైరార్కికల్ క్లస్టరింగ్. అనదర్ నేమ్ ఫర్ దిస్ వన్ ఇస్ డయానా అని కూడా అంటాం. అంటే ఓకే, డైవర్స్ అనాలిసిస్ అనమాట డయానా. అక్కడ వచ్చి ఏజైన్స్ అంటాం అనమాట. దీన్ని ఆంగ్లోమెరిట్ హైరార్కికల్ క్లస్టరింగ్ ని ఏజైన్స్ అంటాం అనమాట. దీన్ని డయానా అని కూడా అంటాం అనమాట. ఇది 2 మార్క్స్ కింద మీకు ఎక్స్టర్నల్ ఎగ్జామ్ లో అడగడానికి ఛాన్స్ ఉంటుందండి. ఆంగ్లోమెరిట్ హైరార్కికల్ క్లస్టరింగ్ ఆర్ ఏజైన్స్ అని కానీ డయానా అని కూడా అడగవచ్చు అనమాట. ఓకే, దిస్ డయానా ఈజ్ ఎ టాప్ డౌన్ అప్రోచ్ అనమాట. వన్ బిగ్ క్లస్టర్ టు స్మాలర్ ఇండివిజువల్ ఆబ్జెక్ట్స్. బట్ కమింగ్ టు ద ఆంగ్లోమెరిట్ హైరార్కికల్ క్లస్టరింగ్ అంటే ఇక్కడ single objects to, okay, that we are starting from the leaf nodes to overall root node. That is a big cluster form చేసుకుంటారు అన్నమాట. ఇండివిజువల్ ఆబ్జెక్ట్ టు బిగ్ క్లస్టర్, దట్ ఈస్ agglomerative clustering. Diverse hierarchical clustering means that is the reverse phenomena related to the agglomerative clustering. Here we are going to start from the one big root. Okay, contains the different objects. From that one to we are going to divide that one to form a individual objects, guys. Okay, okay, okay. Explanation related to the agglomerative clustering, that is the first one. Okay, this is a bottom up approach, man. Okay, bottom up approach means we are starting from the leaf node, that we call them as a single element cluster. Okay, we are starting from the leaf node, that we call them as a bottom up approach anamata. Okay, leaf node start chesukoni we are going to slowly move to the bottom, that is the top, that is the root. We are going to match the leaves. Okay, finally we are going to reach to the root node. In the root node we will have the all the objects. Okay, okay, we will have the all the objects. In the bottom we will have the individual objects. Okay, by combining that one we are going to move to the root node, guys. Okay, that is the second step, guys. Okay, in each step of the algorithm related to the agglomerative clustering, two clusters, okay, those are similar. Okay, we are going to combine, we are going to form the new bigger cluster. Okay, This is the process that is followed in the agglomerative hierarchical clustering. Okay, the each step what we are going to do is we are going to take the two clusters, those will be in a very similar manner, means there is no differences between those two objects, then we are going to combine that one, that we call them as a new bigger cluster, guys. Okay, this process we are going to repeat until we get the big cluster. Okay, in the big cluster we will have the all the objects related to the overall clusters, guys. Okay, దట్ ఈస్ ఆంగ్లోమెరేటివ్ క్లస్టరింగ్. మనం నార్మల్గా చెప్పాలంటే కనుక ఏం చేస్తామంటే కనుక సింగిల్ ఆబ్జెక్ట్స్ తీసుకొని సింగిల్ ఆబ్జెక్ట్స్ నుంచి కంబైన్ చేసుకొని వీఆర్ గోయింగ్ టు మెచ్ దట్ వన్ బేస్డ్ ఆన్ ద సిమిలారిటీ. ఫైనలీ వీఆర్ గోయింగ్ టు ద బిగ్ దట్ వి కాల్ దెమ్ ఎస్ ఎ రూట్. ఓకే, దట్ ఈస్ వై దిస్ వన్ వి కాల్ దెమ్ ఎస్ ఎ బాటమ్ అప్ అప్రోచ్. దట్ ఈస్ ఫ్రమ్ ద రూట్ ఫ్రమ్ ద లీఫ్ నోడ్ టు రూట్ నోడ్. ఓకే, what is the process they will following for the merging is based on the similarities only. The two clusters are similar, means we are going to combine that one. That is in the agglomerative clustering. Based on the similarity only, we are going to combine or merge to form the bigger cluster. Okay, this process, this step we are going to repeat until we get the all the objects, all the points in the big cluster. Okay, that is the ending of the agglomerative hierarchical cluster. Okay, guys. Okay, let us go for the next slide. That is the second type of hierarchical clustering, that is diverse hierarchical clustering. This is the reverse process, that is the reverse phenomena related to the agglomerative hierarchical clustering, guys. Okay, this we call them as a Diana diversity analysis. Okay, here the process that we are going to follow is in the form of top down manner, guys. That is from the root to, that is a big cluster to smaller leaves. Okay, we are going to begin with here in the root node. Okay, okay, in the root we will have the all the objects that is there in the single cluster, guys. Previous one is agglomerative hair cluster. We are going to start from the bottom. Okay, that is the leaves. Okay, then from the leaves, how we are going to form the clusters is based on the similarities. We are going to form a clusters. Okay, likewise we are going to proceed from the top. That is root. Okay, finally in the root we will have the all the objects. That is agglomerative hierarchical clustering. Okay, then the second one is the diverse hierarchical clustering. That is the reverse form process of agglomerative hierarchical clustering. Okay, we call them as a Diana, and that is diversity analysis. Okay, that we call, that is in the top down manner. Previous one is that the bottom up manner. Top down means here we are going to start from the root. In the root we will have the all the objects that is there in the single cluster, guys. Okay, in the each step of iteration related to the diversity hierarchy algorithm, okay, మనం ఇక్కడ ఏ విధంగా ప్రాసెస్ మనం ఇంతకు ముందు చెప్పిన ఆంగులర్ హైరార్కీ క్వశ్చన్ ఏ విధంగా కంబైన్ చేసుకుంటూ వచ్చామంటే అదే విధంగా మనం డివైడ్ చేసుకుంటూ వచ్చేస్తాం అనమాట. మోస్ట్ heterogeneous objects we are going to divide in these. Okay, finally what is the ending step related to diversity hierarchy clustering is, okay, all the objects will be their own clusters. Okay, ఒక్కొక్క ఆబ్జెక్ట్ వచ్చేటికి ఒక్కొక్క క్లస్టర్ లో ఉంటుంది అనమాట, ఎక్కడ కూడా కంబైన్డ్ అయ్యి ఉండవు అనమాట. దట్ ఈస్ ద ending process related to the diverse hierarchy cluster. That is the reverse phenomena related to the agglomerative hierarchical clustering. Okay, in this diverse hierarchical clustering, we are going to start from the root. Okay, we are going to divide that one into individual clusters based on the heterogeneousness. Okay, homogeneous means similar properties ఉన్నట్లు combine చేసుకుంటాం కదా. Heterogeneous means different properties ఉన్నట్లు మనం we are going to divide that one into two. Okay, two clusters. Okay, when what is the ending step related to this diverse hierarchy clustering means, okay, all the objects will be in their own clusters. Okay, ఒక్కొక్క ఆబ్జెక్ట్ వచ్చేటప్పుడు ఒక క్లస్టర్ లో ఇండివిజువల్ గా సపరేటెడ్ గా ఉంటాయి. దట్ వి కాల్ దెమ్ యాజ్ ఎ లీవ్. దట్ ఈస్ వై హియర్ we call them as a top down object. In the top we are going to start from the root. Okay, in the bottom we are going to have the leaf nodes. Okay. Okay, let us go for the next slide. Okay, this is the overall diagrammatical representation related to the agglomerative hierarchical clustering as well as the diversity hierarchical clustering, guys. Okay, in the agglomerative hierarchical clustering, this is the first step, guys. That is, we will have the individual leaf objects, guys. Okay, in the first step, we are going to combine. Okay, those objects having the similar property. For suppose here A and B having the similar properties, we are going to combine that one here. Okay, in the second step, B and E will have the same properties. We are going to combine that one. Okay, in the second step. In the third step, C and B will have the same properties. We are going to combine that one. Finally, we are going to combine this AB and CD that we are going to form as a one root, guys. In the one root, in this agglomerative hierarchical clustering, all the in the root, all the objects will be there. That is, we will have A, B, C, D, E. Okay, all these objects will be there in the root related to the agglomerative hierarchy clustering. We are going to start from the root. Finally, we will get the we are going to start from the leaf. Finally, we are going to get the root, guys. Okay, that is why we call them as a bottom-up approach. Okay, coming to the diverse hierarchical clustering. Okay, the first step is we are going to take from the root. That is why here is the first step. We are going to start from the root. Okay, that is the first 0th step. Next one is based on this dissimilariness. Okay, we are going to divide that one into two different clusters. That is, AB and CD will have the different properties. That is why we are going to divide that one. Likewise, okay, the CDE again divide that one into D. Okay, finally AB is divided that one into A and B individual clusters. In the last step related to diversity hierarchy clustering, we will have the separate objects, guys. Okay, this object is in one cluster, this object is in one cluster. Okay, individual objects will be in their separate one clusters, guys. Okay, that is diverse hierarchy. That is why we call them as a top down approach. That is, we are starting from the root node to finally leaf nodes. Okay, this is the diagrammatical representation for agglomerative hierarchical clustering and diversity hierarchical clustering, guys. All of you write down this diagram. Okay, let us see the algorithm related to this one, guys. Okay, that is agglomerative hierarchical clustering algorithm. Okay, the first and the foremost step related to this basic agglomerative hierarchical clustering algorithm is compute the proximity matrix, guys. Okay, computation of proximity matrix, that is the first step. Okay, and the next step is we are going to merge the two closer clusters. Okay, based on the proximity matrix, it will have the distance between the one cluster to the other cluster. Okay, the next step is we are going to merge the two clusters based on the distance. Okay, the least distance one in the proximity matrix, we are going to combine that one, guys. Okay, the same process. Okay, fine, guys. Can you able to hear my voice? Right, fine. Okay. What is the first step is the preparation of proximity matrix. Okay. The next one is merging the closest clusters. Based on the proximity matrix will have the some values. In that values, what is the least one? We are going to combine those two clusters, guys. Okay. Okay. And again, we have to update this proximity matrix by combining the uh, two combined clusters. Okay, this process we are going to repeat until we get the all the clusters, guys. Okay, in the overall tree representation. Okay, this is the algorithm, guys. Okay, let us then see the example, then you can easily understand what is the process inside. Okay, uh, write down this one algorithm also. Simple thing, guys. First one is the preparation of proximity matrix. The second one is we are going to combine the two clusters with the least distance in the proximity matrix. We have to select, we are going to merge those two clusters. Okay, we have to again, we have to update this proximity matrix based on the previous merge previous step. Okay, the same process we have to repeat. Okay, until you get the one cluster only remains. Write down this algorithm also. In the exam sometimes they will ask this one also, guys. Okay, explain the algorithm related to the agglomerative hierarchy cluster. Okay, guys, simple thing, guys. If you understand the example, okay, in the next slides, okay, then you can easily know what is this algorithm. Nothing is there here. The one thing is the preparation of proximity matrix. It contains the distance between the one cluster to the one object to the another object in the data. Okay, let us see the example related to this agglomerative hierarchical cluster. Okay, first, what is the thing is the proximity matrix. It contains the distance between the pair of units, guys. Okay, the proximity matrix, it contains the distance between the every pair of units. Okay, so suppose, guys, this symmetry matrix or distance matrix, that will be symmetric, guys. Why? Because the distance between x to y as well as the y to x also symmetrical. Okay, same value. That is why uh, the distance matrix will be symmetric one. మన A నుంచి B కి డిస్టెన్స్ ఎంత, B నుంచి A కి డిస్టెన్స్ అంతే కాబట్టి the distance matrix will be symmetrical. We already know that one. And one more over that, guys, in this distance matrix or same matrix, okay, in this distance matrix, we will have the zeros on the diagonal. Okay, why? Because distance between A to A is the zero. That is why diagonal values in this distance matrix will be zero, guys. Okay. Okay, here is the distance matrix, guys. I told you guys all the diagonal values will be having the zero values, and moreover that this one is a symmetric matrix, guys. Why? Is because if you take this one 9, that is the distance between 1 to 2, the same value we have to place it here also. For example, here also 3 to 1, the same distance we have to place it here in the 1 to 3 also. That is why this is a symmetric matrix, guys. This is the distance matrix, contains the distance between one object to another object. 1 to 1 is 0, and 2 to 2 is 0, and 3 to 3 is 0, 4 to 4 is 0, and 5 to 5 is 0, guys. Okay. Okay, this is the distance between 2 to 1, and this is the distance between 3 to 1. This is the distance between 4 to 1 and 5 to 1, guys. And coming to here, this is the distance between 2 to 3, and this is the distance between 2 to 4, and this is the distance between 2 to 5, and this is the distances between 3 to the remaining, and 4 to remaining, and 5 to 5. Why? Because here all the diagonal values are 0. Why? Because the distance between 1 to 1 is 0, and 2 to 2 is 0, 3 to 3 is 0, 4 to 4 is 0, and 5 to 5 is 0. This is the distance matrix, guys. And we also call them as a proximity matrix also. Okay, the same thing. Distance matrix or proximity matrix are same. Okay. In the examination, sometimes they will ask what is the distance matrix means. You have to write down related to the agglomerative hierarchical clustering distance matrix. Okay. Finally, what is the output related to this agglomerative hierarchical cluster is that is dendrograms, guys. Okay, that is a tree-like representation. We are going to get it. That we call them as a dendrograms. What is the second step, guys? We are going to measure the two objects. Okay, based on the distance. Which one is having the least distance? We are going to measure here. What is the least distance here is, guys? Here is the 3, or here is the 2, guys. This is the least distance one, that is between the 3 to 5. Means we are going to measure this 3 and 5. Okay, again we are going to form this distance matrix. Okay, in the distance matrix, the newly updated distance matrix, there is no individual 3 and 5. We are going to combine this 3 and 5 into 1 unit, guys. Okay, 3 and 5 in 1 3 and 5 into 1 unit. That is the next step. Okay, here we are going to measure this 3 and 5. Why? Because that is the smallest distance, guys. That is the smallest distance in the distance matrix. That is why we have matched this one into 3 and 5. Okay, in the next updated distance matrix, there is no separate 3 and 5. Only we will have the merged 3 and 5, guys. Why? Because we have combined that one. Okay, 3 and 5 entities are going to replace that one with a single entity, that is 35 35. Okay, and the next step onwards, okay, in the updated distance matrix, how we are going to take the values means the maximum values for that 3 and 5 we are going to take it, that we are going to include in the distance matrix. 3 లో 5 లో వచ్చేపటికి ఏది maximum value అనేది ఆ పాయింట్ ఉందో దాన్ని మనం మాత్రం తీసుకుంటాం అనమాట. ఓకే, in the updated matrix, guys. Okay, here is the updated matrix. How we are going to get these three values means okay, in the matrix, guys, for let us take this one as an example, that is okay, 1 నుంచి 3 5 distance calculation. From the 1 to 3 to 1 is 3 value. Okay, 1 to 5 is 11 is the value. In this one, which is the maximum value, that is the 11, we are going to place it here, guys. We are going to place this one 11 in the here. Okay, if you observe the diagram. Okay, 3 to 1 is the 3 value, okay, and 3 to 5 to 3 is the 11 is the value. What is the maximum value here? That is 11 we are going to take in the updated matrix. Okay, understand guys? 3 నుంచి 5 నుంచి కూడా 1 కి డిస్టెన్స్ క్యాలిక్యులేట్ చేస్తాం. ఈ రెండిట్లో వచ్చేప్పటికి 3 నుంచి 1 కి 5 3 is the value. 1 నుంచి 5 కి, that is the distance value is 11. In this one, what is the maximum value? We are going to place that one in the, okay, this distance updated matrix. Likewise for 2 నుంచి 3 కి, 2 నుంచి 5 కూడా చూద్దాం. Okay, 2 నుంచి 3 కి this is the value, and 2 నుంచి 5 కి this is the value, that is the 10. In this, which one is the maximum value? 10 is the maximum value. We have to place that one in the updated distance matrix. Okay, likewise 3 నుంచి 4 కి, 3 నుంచి 9 కూడా చూద్దాం. Okay, okay, here 9 is the value. 3 నుంచి 5 కి, 3 నుంచి 9 కి అన్నమాట. Okay, the maximum value is the 9. We are going to take that one in the updated distance matrix. Okay, that is the value we have. We are going to place here is 9 guys. Likewise for the remaining is only, what is the thing we have to take is only the maximum value from the 3 and 5. We are going to update in the distance matrix guys. Okay, likewise we are going to proceed guys. Okay, okay, what is the least value here in this distance matrix guys? If you observe here all the values, so the 5 is the least value, means that is related to 1 and 4. We are going to combine this 2 and 4 into one cluster guys. Why? Because this is the least value, right? Okay, what is the least value? We are going to combine that one, that is 2 and 4 we are going to combine here. Okay, here we have combined the 2 and 4. Okay, again the same process we are going to repeat it guys. Okay, finally after the sixth step, what is the dendrogram we are going to get is, this is the dendrogram guys. 3 5 we are going to combine into one cluster, and 2 4 we are going to combine one into one cluster. If you observe here, what is the least value guys? That is 9 is the least value, that is related to 2 4 and 1. Okay, that is why we have combined this one 2 4 and 1 into 1. Okay, one cluster guys. Finally we have combined uh, this subcluster and 3 5 subcluster into finally one form the one big cluster guys. This is the dendrogram guys. Okay, here we have the distances also in the y-axis guys. Okay, in the y-axis we have already represented the distances also. Okay, if you observe here the previous one, 9 is the value, that is from the 2 4 and 1. Okay, that we have represented here also. Okay, 9 degree we have combined that one. Okay, 3 4, that is the 2 is the value, we have combined it to 4. Okay, coming to the 2 and 4, that we have the value we have got is 5 at the combined with 5 guys. Okay, this is the overall dendrogram representation for agglomerative hierarchical clustering guys. Okay, hope you have understand this one. Okay, tomorrow also I am going to again explain this one. Okay, and I will continue for the next slides, that is db scan. Okay, if at all anybody not understand, okay, listen the tomorrow's class also. Okay, any doubts related to this one, you can ask me. Okay guys, I'm going to end this session. Thank you. Okay.